Welcome to The Explainer. Today, we're diving into one of those super frustrating car problems, the dreaded reduced engine power warning. You know the feeling? If you've seen that pop up on your dash, your heart just sinks. Well, we're going to break down exactly what that P2135 code means, and more importantly, how you can fix it.
So let's set the scene, right? You're just driving along, minding your own business, and then bam! Your dashboard lights up like a Christmas tree. You get this message, reduced engine power, and when you step on the gas, pretty much nothing happens. The car is just crawling, and you're stuck in what mechanics call limp mode. It is definitely a stressful moment, but believe it or not, your car is trying to tell you something really, really specific.
All right, so let's get right into it. The first step in our little investigation here is to understand the code that your car's computer has spit out. This code, it's the key to the whole mystery.
And that code is P2135. Now, the official fancy definition is a throttle position sensor voltage correlation error. So what does that actually mean in plain English? Well, think of it this way. Your car's brain, the engine control module, or ECM, is getting two different stories from the sensors that control the airflow into your engine. It's confused.
Here's a great way to think about it. Imagine you've got two pilots in a cockpit, and each one has an altitude gauge. But one gauge says they're at 10,000 feet, and the other says 5,000 feet. Which one do you trust? You don't. The plane's safety system would sound a big alarm and go into a safe, predictable mode, and that is exactly what's happening under your hood. So, you've got this disagreement happening between the sensors, but what does that feel like when you're the one behind the wheel? Let's break down exactly what you're experiencing. Okay, so you're definitely going to see that check engine light and the reduced engine power message. That's what kicks the car into limp mode, which is why the gas pedal suddenly feels like it's not connected to anything. You might also notice your engine is idling really rough, maybe it stalls out, or you might even have a hard time getting it started in the first place. And get this, your car is doing all of this on purpose. And this is the key thing to remember. This isn't some random failure. Limp mode is a built-in safety feature. Because the computer can't trust what the gas pedal is telling it, it has to prevent the absolute worst-case scenario, which is unintended acceleration. I mean, can you imagine if the throttle suddenly snapped wide open on its own? That would be incredibly dangerous. So to keep you safe, the computer just says, nope, we're done, and defaults to a very slow, very safe power level.
All right, so we know what's going on and we know why the car is acting this way. Now let's put on our detective hats and figure out who the culprit is, starting with the number one usual suspect.
Now, the potential causes are not all created equal. Not even close. In fact, as you can see, one single issue is the bad guy here about 70% of the time. Yeah, you're seeing that right. It's the prime suspect by a landslide.
That's it. The most common cause is a fault inside the electronic throttle body assembly itself. See, inside this part, there are two separate sensors that tell the computer how open the throttle is. And just like any other part, over thousands and thousands of miles, they just wear out. Their signals start to drift apart, and that's what triggers that correlation error we talked about.
Now, even though the throttle body is the main suspect, you can't rule out a few other things. You could have a damaged wire somewhere, or maybe some moisture got into the electrical connector. It could even be a bunch of carbon gunk built up, physically stopping the throttle plate from moving right. Less likely, but still possible, is an issue with the sensor in your actual gas pedal. And then, way down the list, you have a faulty computer. It happens, but it's super rare.
Okay, enough about the what, let's talk about the how. How do you actually fix this? Having a logical, step-by-step plan is really the best way to avoid just throwing parts at the problem and hoping for the best.
And you really want to follow these steps in order. First things first, check for any other codes. If you have one for the gas pedal, deal with that first. If not, move to step 2, a really good visual inspection of the wiring and connector. If all that looks good, try cleaning the throttle body. We're talking about that little metal flap and the housing it sits in. Sometimes just cleaning off the carbon buildup is enough. If the problem is still there, step 4 is where you get your proof. You use a scan tool to watch the sensor voltages in real time. If you can see them not matching up, you found it, and that leads you to step 5, replace the throttle body.
So you've put the new throttle body on, you've cleared the code, you're all set to hit the road, right? Well, not quite. There is one final step, and it is absolutely crucial. You cannot skip this. It's called a relearn procedure, and here's why you have to do it. Your car's computer has spent years, maybe a decade, learning and adjusting to the signals from the old failing part. Now, you've dropped in a brand new, perfectly working one, and the computer is kind of confused.
You have to introduce them properly so the computer can learn the new part's baseline for a perfect idle and throttle response.
Now, this here is a really common type of relearn procedure, just to give you an idea of what it looks like. And listen, this is really important. This is just an example. The exact steps can be different for almost every make and model, so you have to do a quick online search for the specific relearn process for your exact car to make sure it calibrates the right way.
You know, when you step back and look at this whole process, you've gone from a digital error code to a physical part swap and then back to a software calibration. It really brings up a much bigger thought about what it means to work on cars these days.
The big takeaway here isn't just about how to fix one little code. It's a perfect snapshot of how our cars have fundamentally changed. Fixing them isn't just about wrenches and sockets anymore. It's about understanding this complex digital dance between sensors and computers. As our cars get smarter and more complex, you have to wonder what the future holds for the person who just wants to fix their own stuff in their own garage, right? Makes you think, doesn't it?